Welcome to Mrs. Merkel's Trig class. Let's start with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri et Filii, Spiritus Sancti. Amen. Okay, so this is trigonometric functions, chapter 12-2, take 2. Turns out that I guess the pen isn't going to work, so we're going to have to go back to the permanent marker, which I'm not a big fan of, but we'll have to see how it goes. So this is 12-2, trigonometric functions and angles. So, like I said before, we're used to having triangles that are they just give you the triangle, but now we're going to have our triangles that are going to be on the x and the y axis, okay? So the triangle starts on the initial side is on the x-axis, and the terminating side is over here, okay? So the distance from here to here is x, and the height is y, and the hypotenuse is r. So if we use the Pythagorean theorem, r squared is equal to x squared plus y squared. Okay, so now let's talk about our trig functions. So we know that, if you remember from before, we know that the sine of theta is equal to the opposite over the hypotenuse. So in our case, this is our angle theta, which is going to be a little tight to write, but I think we got it. Okay, our angle theta is in there. Okay, so the sine of theta is equal to opposite, which is y, over the hypotenuse, which is r. So that's going to be y over r. Okay, so we have the cosine of theta is equal to the adjacent over the hypotenuse. And in our case, the adjacent is x, so it's x over r. And the tangent of theta is equal to the opposite over the adjacent, which is y over x in our case, okay? Now, when they ask problems of this type, what they're going to do is they're going to say, they're going to give you a point. So let's say they give you a point 4,5. So we go over here. We go over 1, 2, 3, 4, and up 1, 2, 3, 4, 5. And this is the point 4,5, okay? And then they're going to ask us some questions about the angle that's created when we draw the line out to the point 4,5, okay? So what we know that this is 4 and this is 5, okay? To start off, we know that this is a right triangle. So we have the x and the y value, but we don't have the value for the hypotenuse. So we use this up here. So we say r squared is equal to x squared plus y squared, okay? So r squared is equal to 4 squared plus 5 squared. So r squared is equal to 16 plus 25. R squared is equal to 41. So when we solve for r, we take the square root of both sides, and we get r is equal to the square root of 41. Okay, so now we can use our trigonometric functions to find out what the sine of theta is. The sine of theta is equal to y over r. Okay, so in our case, y is 5, and r is the square root of 41. So the problem is we're not allowed to have the square root of 41 in the denominator, so we need to rationalize the denominator. So we're going to multiply by the square root of 41, the numerator and the denominator. So your answer is going to be 5 square roots of 41 over 41. Because remember, the square root of 41 times the square root of 41 is just 41. Okay? So now let's take a look at the cosine of theta. The cosine of theta, if we look up here, is equal to x over r. Well, x is equal to 4, so it's going to be 4 over the square root of 41. We multiply the numerator and the denominator by the square root of 41 to rationalize it. We're going to have 4 square roots of 41 over 41. All right? So, one more trigonometric function to do. Part of the problem was that this was... the permanent marker goes through, so we're going to try this new method so that we don't go through a ton of paper. All right, so let's take a look here now. So we'll put this over here for a minute so that we remember what we're doing. And we know that the tangent of theta is equal to the y over x. So in our case, y is equal to 5 and x is equal to 4. So tangent of theta is equal to 5 over 4. All right, so now let's take a quick look. We have some new terms to learn. If you have learned them already, then this will just be review. Okay, I don't like that shadow there very much. All right, so let's take a look. So let's say we have the cosecant, C-O-S-E-C-A-N-T, the cosecant of theta. All right, the cosecant of theta is written CSC theta, and the cosecant is defined as 1 over the sine of theta. All right, and we know that the sine of theta is y over r, so 1 over that just means that we flip it, so that is equal to r over y. All right, the next term is the secant of theta, and that is written SEC theta is equal to 1 over cosine theta. All right, we remember from before, cosine theta is equal to x over r, so the secant of theta is equal to r over x. All right, and the last one that we need is tan theta. Tan theta is equal to, cotan. Oh, well, that looks terrible. Let's just cross that right out altogether. It's not the tan, it's the cotangent. C-O-T-A-N-G-E-N-T. Cotangent of theta is equal to COT theta, which is equal to 1 over tan theta, which is equal to x over y. Okay, so basically all we're doing is we're flipping. This was y over r, so we flipped it to r over y. And we did the same thing for the secant and the cotangent. Okay, so now let's take a look at, remember our example, which we have over here. Okay, so if we want the cosecant of theta, it's just going to be, you're going to flip the sine of theta. So our sine of theta was 5 over the square root of 41. So it's going to be the square root of 41 over 5. All right? We just take it before we rationalize the denominator, because whenever we have the inverse of it, it's just going to be the square root of 41 over 5, and there's no need to rationalize the denominator. All right? So the secant of theta is equal to, we go back and look at the cosine. The cosine was 4 over the square root of 41, so it's going to be the square root of 41 over 4, okay? And the last term is the cotangent of theta. The tan of theta was equal to 5 over 4, so the cotan of theta is equal to 4 over 5, okay? All right, so let's get moving here to some trig identities. Change our paper out. So you can start writing trig identities at the top of your notes. All right, so these are important, and we're going to learn how to work with these. These are trig identities. All right, so if you've learned this before, then this is review. That's great. Tan theta is equal to the sine of theta over the cosine of theta, okay? But also remember, we now know what the cotangent of theta is, and that's just the inverse. So the cotangent of theta is equal to the cosine of theta over the sine of theta, okay? The next trig identity we need to know is sine squared theta plus cos squared theta is equal to 1. You might be saying to yourself, what is this? It's just the way the math department likes to write sine squared theta. What it actually means is, it means the sine of theta squared plus the cosine of theta squared is equal to 1. Sine squared theta is the same thing as sine theta squared. It's just a different way to write it, okay? All right, so let's see where we're going with our trig identities. Now, in the book on page 559, we're going to look at an example of this, okay? What they give us is that they give us sine theta, and they ask us to find cos theta and tan theta, okay? So for number 9, I'm just going to double check on that they give us, because I filled this table out before when I did this lesson before. So they give us the sine of theta is equal to 3/5. Okay? So how are we going to work this out? How are we going to find out what the cosine of theta is and what the tan of theta is? All right? So we use the information. We know that the sine of theta is equal to 3/5. We're going to use this trig identity here, the fact that sine squared theta plus cos squared theta is equal to 1. All right, so what we're going to do is we're going to plug in. We know that the sine of theta is 3/5, so we're going to plug in 3/5 squared plus cos squared theta is equal to 1. All right, now look at this. We're going to be able to solve for the cosine of theta, so we'll be able to put that in our chart. Okay, so 3 squared, remember when a fraction is squared, you square the numerator and you square the denominator. So we have 9/25 plus cos squared theta is equal to 1. Now I'm going to subtract 9/25 from both sides, so I'm going to have cosine squared theta is equal to, now it's going to be 1 minus 9/25. So instead of writing 1, I'm going to write 25/25 minus 9/25, because 1 is equivalent to 25/25. I was just getting a common denominator. Okay, so the cosine squared theta is equal to 25 minus 9, which is 16/25. Okay, that's cosine squared theta, but that's not what we're looking for. We're actually looking for cosine theta, so we're going to have to take the square root of both sides. So let's take a look at what this looks like. So we take the square root of both sides, and we get that the cos of theta is equal to 4/5. Okay? Now, we're not quite done with the problem yet, because when they were looking for it, they were looking for, so we can fill this in. In fact, I'll put the new information in black so that you can see it. The sine of theta is 3/5. The cosine of theta is 4/5. Now they're asking us what the tan of theta is. So we can use another method to find out what the tan of theta is, and we can use one of those other trig identities. See how the tan of theta is equal to the sine of theta over the cosine of theta? So let's take a look. So tan of theta is equal to the sine of theta, which was given, that is 3/5, divided by 4/5. Now, if you remember from algebra class, we did something that we called keep, change, flip. Okay? When you have a fraction divided by a fraction, you keep your first fraction, you change it from division to multiplication, and you flip your second fraction. Okay? So the 5s will cancel out, and we have 3/4. So that means tan of theta is equal to 3/4, and we can fill that in the chart. And you'll take a look, you can see this chart in your book. Okay? All right, let's take a look at, that was number 9. That's the answer for number 9. Let's take a look at number 12. So for number 12, they tell us, and just don't abandon the process. Do it exactly the same that what we're used to. They tell us that the sine of theta is equal to the square root of 2/3. So if you look in the book on page 559, there'll be this table that looks like this, which I know is probably hard to see, but basically the information that they give us in number 12 is that the sine of theta is equal to the square root of 2/3. Okay? So what we're going to do is we're going to use our trig identities, and we're going to say that the sine squared theta plus the cosine squared theta is equal to 1, okay? So we're going to plug in the square root of 2 over 3 squared plus cos squared theta is equal to 1. When we square this, the square root of 2 squared is just 2, and 3 squared is 9, okay? Plus cos squared theta is equal to 1. We're going to subtract the 2 over 9 from both sides, so we're going to have cosine squared theta is equal to. Now I'm going to write that 1 as 9 over 9 so that I'm ready to subtract so that I have a common denominator when I subtract the 2 over 9 from both sides. So now we have that the cosine squared theta is equal to 9 minus 2 is 7, and the cosine squared theta is equal to 9 over 7. All right, so we want to find out what the cosine of theta is. So we're going to take the square root of both sides. So it's going to be the square root of 7 over the square root of 9, which reduces to the square root of 7 over 3. Okay, so the last one that looks, take a look. Now they want to find out what the tan of theta is, so we can fill out that chart. I think doing 2 of these really helped. It made me realize what I was doing, so I'm going to give you 2 of those for homework, okay? So let's take a look. So we know that the tan of theta is equal to the sine of theta over the cosine of theta. Well, we were given that the sine of theta is the square root of 2 over 3, okay, over the cosine of theta, which we just found to be the square root of 7 over 3, okay? So we're going to do our keep, change, flip. We keep our first fraction as the square root of 2 over 3. We change it from division to multiplication, and we flip the second fraction, which is this 3 over the square root of 7, okay? The 3's cancel out. You're left with the square root of 2 over the square root of 7. The problem is we're not allowed to have a irrational number in our denominator. We have to rationalize that. So we're going to multiply the top and the bottom by the square root of 7. The square root of 2 times the square root of 7 gives me the square root of 14. Square root of 7 times the square root of 7 gives you 7. So your answer for that problem is the square root of 14 over 7. All right, now let's keep going along here. Now the next thing is something called cofunctions. The book really doesn't do a lot yet with cofunctions, but I'm guessing that we'll have more to do with them later. But what they do give us is they give us a triangle that looks like this, okay? This is angle A. The angles are uppercase. This is angle B, and this is a right triangle, and that's angle C, all right? The side, which is opposite the angle, is a lowercase a. The side, that's a lowercase b, and that's a lowercase c, okay? And let's talk about what it means to be a cofunction. So we have the sine of A is equal to, now let's take a look. The sine of A is equal to the opposite over the hypotenuse. So that is going to be A over C. Okay, now the cofunction with sine is going to be cosine, and it's actually the cosine of B. But why? Let's take a look. If I look at B and I take the cosine of B is the adjacent over the hypotenuse, which is A over C. So the sine of A is equal to A over C, but the cosine of B is equal to A over C. All right, so let's take a look at 2 more cofunctions. The tangent of A, remember the tangent is the opposite over the adjacent, so that would be A over B, okay, and its cofunction is cotangent, okay, and if I look at the cotangent of B, it's going to be the inverse of that, the inverse of the tan, which is B over A, but then when you flip it, it's going to be A over B, so those 2 are cofunctions. And the last one is the secant of A is equal to C over A, and its cofunction is the cosecant. Okay? What's most important to remember about these cofunctions, they only work if and only if A plus B is equal to 90 degrees. All right, what does it mean for A plus B to be equal to 90 degrees? It means that we have a right triangle, okay? okay? If A and B are 90, that leaves 90 degrees left for C. So the cofunctions only work with the right triangle. Now, so far, the hardest example that they have with these is they'll give you something that looks like the cosine of an angle is equal to the sine of 40 degrees, okay? So what we know is from this, we know that angle A plus angle B is equal to 90 degrees, okay, because they're cofunctions. So that from that, we can tell that our angle is equal to 50 degrees, okay? Because these two angles, the 40-degree angle plus this angle, A plus B must equal to 90 degrees, okay? So that's how we can find that. And those are easy examples, and those are in your homework. I think I only gave you one of those because it's really not hard. You just have to get where the angles add up to 90 degrees. Okay, now let's take a look at our next sheet. Now, this one is going to be a little bit more difficult to write with the marker, so let's take a look. Now, they take a look at two different triangles. This is in a blue box. It's on page 558. And the note in the book says you can either memorize this table or you can figure out how to fill in the table. I'm not a big fan of memorization because sometimes I forget things. So I like to know how to fill out a table, all right? So let's take a look at the first one here, all right? We have a triangle like this. And this triangle is a 30, 60, 90 triangle, all right? And we have this side is 1, this side is the square root of 3, and this side is equal to 2, okay? So what they want to do is they want to figure out if we know that if we're looking at the 30-degree angle, okay, they're asking us what is the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent, okay? So all they're doing is okay, they're looking at this here, the 1, the 2, and the square root of 3, and they want to know what the sine is. And this is going to come in with the unit circle later, but right now we just need to be able to fill out this chart. We know that the sine is the opposite over the hypotenuse, okay? So the sine of the 30 degrees is going to be equal to 1 over 2. All right, the cosine is the adjacent over the hypotenuse, so the cosine is going to be the square root of 3 over 2. Okay, the tangent of 30 is opposite over adjacent. Now the problem is that is 1 over the square root of 3. Okay, the problem is that we can't have the square root of 3 in the denominator, so we need to rationalize it. So we're going to multiply the numerator and the denominator by the square root of 3. So the tangent is going to be the square root of 3 over 3. Okay? The cosecant, remember, is the reciprocal of the sine. So if I flip 1 over 2, it's just going to be 2 over 1, or 2. Now for the secant, we have to flip the square root of 3 over 2, okay? So that's going to be 2 over the square root of 3. The reason I write it over here is because I noticed that I'm going to have to rationalize the denominator. So when I multiply, I'm going to have 2 square roots of 3 over 3, okay? And the cotangent, remember the tangent was 1 over the square root of 3, so the cotangent when we flip it is just going to be the square root of 3, okay? So what I want you to do is I want you to make your own, put the blue chart in your notes. It's very important. I want you to have that in your notes, okay? Then what you'll do is you're going to fill it out for the 30 degree and the 60 degree, okay? And that will come from this triangle, all right? And then the other one is triangle where we have a 45-degree angle, a 45-degree angle, and a 90-degree angle, okay? This is 1, okay, just the same. Okay, this is 1, and this is the square root of 2, okay? So then what you're going to do is that you're going to then fill out for 45 degrees. Now, you guys can do 60 degrees on your own, okay? So sine of 60 degrees is the opposite over the hypotenuse, okay? And which is the square root of 3 over 2. And you can just fill that out. You need to have this in your notes because you're going to reference it later, okay? So, but now let's take a look at 45 degrees, okay? Now the 45-degree one is so easy because everything matches up, okay? So the sine of 45 degrees is equal to the opposite over the hypotenuse. So that was going to be 1. I'm going to write it over here on the side, 1 over the square root of 2. So when we rationalize the denominator, you're going to have the square root of 2 over 2, okay? That is for the sine, and the sine and the cosine, it's going to be the same. So it's going to be, this cosine is going to be the square root of 2 over 2, all right? The same as the sine, all right? Because of the nature of those angles being the same. The tangent is the opposite over adjacent, so that's going to be 1 over 1, which is equal to 1. The cosecant, now remember, the cosecant flips the sine, okay? So that's just going to be square root of 2, okay? And the secant will also be the square root of 2, okay? And the cotangent, we have to flip the tangent, so 1 over 1 flipped is just 1, okay? So you guys, I want you to fill out that. You should have this chart in your notes. If you can't see it very well, I want you to look it up on page 558, and I want you to fill in the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent, all for that 60-degree angle. It's going to become very important with the problems that we're going to do going forward, okay? So for your homework now, I'm going to show you what one of these homework, you're probably saying, what in the world am I going to do with this blue chart? Well, I'm going to show you how they work problems with the blue chart, okay? So this is going to be like one of your homework problems. So I'm on page 560, all right? And they show us what our little triangle looks like here, okay? Oops, that doesn't look like a 90-degree angle. Let's redraw that. I don't like, for some reason the book draws them backwards and it makes it challenging for me. So let's try to see if I can make a 90-degree angle at least a little bit better, okay? There we go. We'll draw the 90-degree angle first, okay? So this is A, B, and C, okay? Side A, side B, and side C, okay? So let's take a look at number 22. They tell us that C is equal to 10 and angle A is equal to 45 degrees, okay? So here's what we have. Let's take a look at this. We have now, we know that A is equal to 45 degrees, all right? So we say that the sine of A is equal to, so take a look, here is A, the sine of A is equal to the opposite over the hypotenuse. So that is going to be A over C, but we know that C is equal to 10, okay? So the sine of A is equal to A over 10, okay? But we know from our blue chart, we know that, let me pull the blue chart back here. Okay, we know that the sine of 45 degrees is equal to the square root of 2 over 2 from our chart, okay? So what we can now say is the square root of 2 over 2 is equal to A over 10. Okay, and that's where that chart comes in because we have the sine of A, and the sine of A, when you look at that, the sine of this is the square root of 2 over 2, okay? So we just cross multiply, so you have 2A is equal to 10 times the square root of 2. We're going to solve for A by dividing both sides by 2, so you get A is equal to 5 square roots of 2, all right? because of the nature of this, because A is 45 degrees, that means B is 45 degrees. And they're telling us they want to know all the angles and all the sides, okay? So if we know that angle A is 45 degrees, we also know that angle B is equal to 45 degrees because we're told that this is a right triangle. The sum of the angles of the triangles have to equal 180 degrees, all right? And also, we know if we're looking at the cosine, okay, of A, is equal to the opposite, cosine of A is equal to the opposite, the adjacent, that would be B over 10. But we know that these are exactly the same. You can work it out, but you will find because the angles are the same, the sides opposite them are the same. So we can say, you guys can work that out if you want, but the B is equal to 5 square roots of 2, okay? So we found the side A and side B were the same. They were 5 square roots of 2. We were given C is 10, A and B are 45, and C is equal to 90 degrees. All right? So let's take a look at now. So the ones with the 45 degree angles are easier because the sides are matching. All right, so that was number 22. Let's take a look at number 20. Okay, so for now, number 20, we are given that A is equal to 6 and angle A is equal to 30 degrees. Okay, so let's take a look at that. You know what? What if I put it right here? There we go. That'll make a nice 90-degree angle. Okay, so this is A, this is B, okay, this is C. So we are given that A is equal to 6, and we need to find the other two sides of the triangle. And we also know that angle A is equal to 30 degrees. All right, so let's take a look. How are we going to solve this? We need to use, let's solve for C first, okay? Now, let's take a look here. So we know that the sine of A is equal to the opposite over the hypotenuse. So that is going to be 6 over C, okay? So the thing is that we definitely want to make sure to get used to using our chart because it comes in handy later, okay? The sine of a 30-degree angle is equal to 1 over 2. You'll have that in your blue chart, okay? So what that means is that 1 over 2 is equal to 6 over C. We're going to cross multiply, and you get C is equal to 12, okay? So let's put that on our chart here. That's 12. Okay, now I know you're saying to yourself, I can use a squared plus b squared is equal to c squared to find this missing side. But instead of using the Pythagorean theorem, let's take a look at what we can use from our blue chart. Okay, so what we know is we want to include the missing side. Okay, so let's take a look at the opposite over the adjacent. Okay, so what that would be is the tan, and you guys should play with these and try them and see different things. The tangent of A, the tangent of 30 degrees, is opposite over the adjacent. Okay, and that's going to be the side that we're looking for. So is equal to 6 over B. Okay, so, and if you take a look at our blue chart, the tangent of 30 degrees is equal to the square root of 3 over 3. So we have the square root of 3 over 3 is equal to 6 over B. Cross multiply, we have B times the square root of 3 is equal to 18. Divide both sides by the square root of 3, and you get B is equal to 18 over the square root of 3. But the problem is we have to remember to rationalize our denominator. So you're going to have 18 square root of 3 over 3. Divided by 3, it's going to be 6 square roots of 3. So side B is 6 square roots of 3. Okay? So we know that angle A is 30 degrees, and we know that angle C is 90 degrees. So we can also tell that angle B is equal to 60 degrees. And that's all the information, all the sides and all the angles that they were looking for. Okay, let's take a look at one more example so that you've seen all the examples. Let's take a look. Let's take a look at number 24. Okay, for number 24, we have that A is equal to 3 and C is equal to 6. All right, let's fill out our triangle over here. Okay, this is A, B, C. Okay, side A is equal to 3 and side C is equal to 6. I know you're probably saying, yes, Mrs. Merkel, I can do the Pythagorean theorem. But the thing is, I know you already know how to use the Pythagorean theorem. I want you to practice using the blue chart because it becomes important later. All right, so let's take a look here. What we have let's take a look. We want to find out what, let's see, let's say, isn't that funny? I did the sine of A is equal to the opposite, which is 3 over 6, okay? The sine of A is equal to 3 over 6. If you go back and look at your chart, the sine of A is equal to, let's see if I can find, I lost the blue chart. The sine of A is equal to 3 over, oh, I remember now. The sine of A is equal to 3 over 6, which reduces to 1 over 2. If we know that the sine of A is equal to 1 over 2, what do we know about angle A? If you go back and look at the blue chart and you find where the sine of A is equal to 1/2, you'll find out that where the sine of A is equal to 1/2, that angle A is equal to 30 degrees. So see, we're kind of going the other direction. We're looking in the chart, finding where the 1/2 is, and then finding out what the angle is, okay? So we know that that's equal to 30 degrees. So what we can do, so now we need to we still have to find B. So how are we going to find B? Let's take a look. Let's say I did the sine of A is equal to, actually, excuse me, I misspoke. Let's look at the tangent because we want to have something that includes B, okay? So if I have the tangent of A is equal to the opposite, which is 3 over B, okay? We just found that the tangent, we just found that angle A is 30 degrees, so it's going to be the tangent of 30 degrees is equal to 3 over B. Now I really need to find that chart because I didn't actually write this down. I did it a different way. I did it the way that I said that I didn't want you to do it before. Okay. I did on the one previously, I did the Pythagorean theorem, but let's take a look. Let's make sure that it works. So the tangent of 30 degrees is equal to the square root of 3 over 3 is equal to 3 over B. All right, let's see if this works. So we cross multiply. The square root of 3b is equal to 9. Okay, divide both sides by the square root of 3. And we get b is equal to 9 over the square root of 3. But we have to rationalize the denominator. So we get 9 square roots of 3 over 3. Okay, 3 goes into 9 3 times. So your answer is going to be 3 square roots of 3, which is what I got when I was doing the Pythagorean theorem. So it works. Okay, last thing, I had your homework assignment written down here. But I have it posted in Jupyter Ed, so I'm not going to rewrite it on the video. Take a look at the homework assignment that's posted in Jupyter Ed, and remember, it's not due tomorrow because this video is so late. We'll have it due on Thursday. Hopefully, I'll post another video. We have to get at least one more in this week is my plan. All right, well, take care, and I will see you tomorrow. God bless you. Have a nice night. Bye-bye.